This is part 3 of our project. I, Alyssa Polanco, am presenting questions 7, 9, and 11.
Hi, I'm Jasmine Castro, and I will be explaining questions number 8 and 10.
Question 7 asks us to use a whisker plot to estimate the shape of distribution. Here you can see our whisker plot graph from StatCrunch. On our data sample of baby weights, based on the graph, the minimum value is 0 pounds, which is the possible outlier in our data, and the maximum value of 11.5 pounds. As the IQR is near the maximum value, the distribution is likely skewed to the left. Here you could see our graph, and we're moving on to question 8.
For question 8, we are asked to either use empirical rule or Chebyshev's theorem to provide a prediction that is within 3 standard deviations away from the mean. Our distribution was not bell-shaped, so we used Chebyshev's theorem. From our previous calculations, we used our mean of approximately 7.3687 and our standard deviation of approximately 1.2608. These values were plugged into the Chebyshev's formula. As you can see, by the Chebyshev's theorem, we have at least 88.89% data within 3 standard deviations away from the mean. The weight interval is 3.5863 and 11.1511 pounds.
On to question 9. Okay, so question 9, we created a confidence interval for the population mean using a confidence level of 0.90. Our number of values used was 249, which gave us a degrees of freedom of 248. Since our confidence level was 0.9, we used an alpha of 0.10 and alpha divided by 2, which gave us 0.05. After computing the critical values using the inverse t, we got t equals 1.651, as you can see here depicted in our graph from StatCrunch. Using our t value, here you could see our code and our graph, and then we placed it again here. Using our t value of 1.651 and the standard deviation of 1.2608 and our our n value, we got a standard error of e equals 0.138. Using our answer for the standard error, we ended up plugging in our values into our confidence interval formula. From this, we got an interval of 7.2369 and 7.5005 pounds when using a C level of 0.90. Here you can see our StatCrunch output, which shows the outputs for the one sample t-summary confidence interval.
And so for question number 10, we created a confidence interval for the population standard deviation using a 95% level of confidence. In order to get the chi-square critical values, we inputted 248 degrees of freedom into the StatCrunch, and our results for chi-square left was approximately 206.273, and chi-squared to the right was approximately 293.512. To get the 95% confidence interval for sigma, we plugged in previous values into our confidence interval formula to obtain our interval with a lower limit of 1.1589638804 and upper limit of 1.38248843.
On to our last question, which is number 11. Question 11 asks us to design a hypothesis test for the mean proportion variance or the standard deviation. So we decided to run a hypothesis test for our mean. Our claim Sorry, guys. Our claim states that the mean of baby weights is 4.5 pounds. Our null hypothesis was mu equals 4.5 pounds, and our alternative hypothesis was mu is not equal to 4.5 pounds. In order to get our critical value, we use the inverse T code to get T equals 1.651, as you can see here on our okay. As you can see here on our StatCrunch graph output, we then used our previous values to plug into the test statistic formula, which gave us T equals 35.9. Our final conclusion was to reject HO. There was sufficient evidence to warrant rejection of the claim that mu is equal to 4.5, since the test statistic of T is equal to, or approximately equal to 3.9 is greater than the critical value of T equals 1.651, using a significance level of alpha is equal to 0.10 and confidence level of 0.90. And that was the end of our third part.
Thank you so much for listening to us.
Thank you.